Okay, first of all, a brief recap what we have learnt is in last couple of classes. Or so, am I audible? If anyone can confirm, then I will proceed. Hello, am I audible?
Yes, sir.
Okay, so let me go with the recap of what we had learned in these classes. So first of all, basic concept of stress and strain. Okay, then basic concept of stress and strain. Then we had learned about the Mohr circle. Then just after that, we go with the bending and SFD and BMD diagram, means shear force diagram and bending moment diagram, and this leads to bending stresses and shear stresses. Bending stresses and shear stresses. Then after that, we discussed about the torsion and slopes and deflections. So what we left after this from the syllabus is and also the experiment, means testing, we UTM, impact testing and hardness testing. So what we left is let me write the left portion. The left portion is your Euler buckling load, Euler buckling, or in columns that is happening. Then your strain draw sets and your shear center. So these are a few topics that left, and these are not very big topics. So what I thought is just I made very quick in the going with the Mohr circle concept of stresses, SFD BMD. So I am going with with the questions that are asked in the previous year. So to refresh your concept, because if without question these concepts are just for no use, and in GATE they are just asking about the questions, not the concept. So I made a preparation for your previous year GATE. So I am going to discuss that. Then after, if today permits, we will discuss Euler buckling, and in next class we will discuss these two concepts and questions from these two concepts. So this concept is added in 2021, I think, and in mechanical engineering, and similar it is asked from previous also. But the theory is the questions came from the theory portion only. There is no any numerical part what I learned from the courses I saw. And in strain draw sets, we have one questions are in mechanical, and maybe one in civil it is not present. So first of all, we will discuss some questions to refresh your concept, because it is 1 week and I don't know whether you practice the question or not. So first of all, I am going to discuss the questions from the previous year, and it may be very helpful if you are with me in the whole class. Okay, it will not be boring. So just this I made for you. This is a whole question set. So I am not going to discuss everything. I will provide you with the PDF format. I am going to discuss where you can stuck. Is it okay to everyone? Hello.
Okay, sir.
Oh, okay. So any of the students, if any problem in between, then they may ask. Okay. So first, what from the stress concept, stress is equal to force by area. This is the basic concept in simple stresses, and stress is equal to your modulus of velocity into strain up to yield point. These two concepts you remember, and your relations. That is, what is the relation? That is E is equal to 2C 1 plus mu is equal to 3K 1 minus 2 mu. Now I made you remember how to learn these things. Just it is 1 plus 1, the coefficient of mu is 1, so 1 plus 1 2, so I put 2 here, and here it is 2, it is 1, so I put 3 here. So learn these two things. This will be very helpful in exam. Now in this question, the first question that is this is 1 marks question that asked in GATE examinations. So this is a previous year question around 30 years, so means you can see the pattern and it is not very difficult. Okay, so first of all, the first question is, a large uniform plate containing a rivet hole is subjected to uniform axial tension of 95 megapascal. So maximum stress in the plate is, okay, so it is given there is a hole in between the plate and a force is a tension of 95 megapascal is applied. Now it is asked, what is the maximum stress in the, means this is a pressure force, I think because it is megapascal, so this is a pressure, and you have asked about the maximum shear, maximum stress. So you know the formula, the first, what is the basic formula? Sigma is equal to F by A. So this maximum occurs when the area is minimum. Now area is minimum in this is at this portion. If you take this portion of the plate, area is minimum at this point. Okay. So first of all, we convert the 95 megapascal into force. What is the force is acting? So sigma is equal to, at this point, 95 megapascal. Now if we multiply it with area, we get force. So what is the area first? 95 megapascal into 10 centimeter, we convert into mm. Let's, it is 100 mm into the thickness, because thickness is not given. Let us assume that is T. Now this is the force that is acting on this plate. Now where it is maximum? At this portion. So what is the area at this point? Area at this point is sigma, because force is uniform along the plate. So the force will be equal to sigma into 100 minus 5 minus 50 into T. The force is uniform along the whole point. So we first obtain the force. So this is your force. Now if we just, the force is equal to sigma into stress, sigma into area. Now sigma is everywhere, here sigma is sigma 1, suppose here sigma is sigma 2. Now force is constant along the plate, so we just equate the two terms and we get the value of, your sigma here, this value, maximum stress, sigma m. That value is 95 into 100 divided by 50, that is 190 megapascal. So your correct answer is 190 megapascal, answer C. Now the second question, I will, after one page, I will ask anyone has any doubt, then you can say. Now the second question is given, a free bar of length 1 meter is uniformly heated from 0 degrees Celsius to a temperature T degrees Celsius. Alpha is the coefficient of linear expansion and E is the modulus of elasticity. The stress in the bar is, so you can see this question, in this question it is not written that your rod is rigidly held in between. Okay, it is not said that. So what it is lying on a free bar. Look, it is written a free bar. So free bar is, it is put on a table. Okay, now it is heated and it is free to elongate in any direction. So thermal stress in this, I had just told you, without any constraint around the boundary, the thermal stress will be 0. So here the option is C. Your third question is, now two identical circular rods of same diameter and same length are subjected to magnitude of axial stress. One of the rod is mild steel having modulus of elasticity 206 gigapascal. The other rod is cast iron having modulus of elasticity 100 gigapascal. Now it is given, assume both of the materials to be homogeneous and isotropic. What is the means of homogeneous and isotropic? The Young modulus at any place is same, equal to E. That is called homogeneous material. Now what is the meaning of isotropic is, at any direction your E doesn't change. Now suppose this is your material, at one point this is 1 point, this is 2 point. Now at these 2 points your E will be same, then it is called homogeneous. Now at this direction it is also E and at this direction it is also E, so it is called isotropic. Okay. Now same axial force causes the same amount of uniform stress. It is causing same amount of uniform stress. Then which of the following observation is correct? So as you know, stress is directly proportional to strain. So if this is constant, now the strain is inversely proportional to modulus of elasticity. Now what that means is, whose value of E is greater, then that at that portion the strain will be smaller. So where the if we considered mild steel, the modulus of elasticity 206 gigapascal. So you can say that the strain in mild steel is less than strain in cast iron. Okay, so this will be your answer, that is cast iron elongates more than the mild steel. Your option C. You can say the question is if you just say, so if E is greater, then your option C is correct, because cast iron elongates more because its E value is less. I hope everyone is going with this. Okay, yeah, it is right. Now fourth question is, in terms of mu Poisson's ratio, the ratio of Young modulus to shear modulus of the material. So I have written just here, you can see that this you have to learn. E is equal to 2C 1 plus mu. So the ratio will be E by C is equal to 2 1 plus mu. Okay, so this will be your answer for question number 4. And your question up to this, anyone has any problem? Please, it is for your benefit, so I am asking, anyone has any problem?
No, sir.
Okay, so if this leads to boring of the questionnaire, then we can discuss the concept. So if you are get bored with the questions, then ask me, I will discuss some concepts of the left. So next I will then discuss your. Okay, so just remind me, sir, that it is get bored, so I will take the class for that. So what is next question is, a uniform slender cylindrical rod of a homogeneous and isotropic material. So everyone please remember, when it is given homogeneous and isotropic, you know what is the meaning of that. And in 1 marks question it may be asked, in homogeneous, that at any point on the surface, at any point, your material property is same. Your material property is same. And what is the meaning of isotropic? Isotropic means in any direction at one point, in any direction at one point, your material property is same. What is the meaning of that? Suppose, just like I said, you have 2 points. Now at this point also the value of E, Young modulus is E and here E. But if take this single point and if you take the 3 perpendicular directions, then the value is also E. So this is called isotropic. And if at 2 points the value is same, so it is called homogeneous. When it is called homogeneous and isotropic, then at this point also it is E, it is E, it is. So at every point and at every direction the value is your Young modulus. I hope this is clear to you. So it is given a uniform slender cylindrical rod is made up of homogeneous and isotropic material. The rod rests on the frictionless surface. The rod is heated uniformly. If the radial and longitudinal stress are represented by sigma r and sigma z, then what is the value? So first of all, again you have to see, here it is given the bar is putting on the surface, okay, and it is lying without any constraint. Now what can be the constraint at the one point is the surface, but here it is given frictionless surface. So in expanding the rod, there is no any frictional force is coming, so no stress is coming. So the rod is freely to expand in any direction. Then your radial and longitudinal stress is 0. So don't think because it is lying freely. So the basic concept that you can revise from your thermal stress is, until and unless the body is constrained in between supports, there will be no stress in the bar, no thermal stress. So you need to remember this. This is very important concept. Now next question is, a steel bar of rod L and length L and diameter D is fixed at ends. Okay. Now it is uniformly heated to a temperature rise of delta T. The Young modulus is given E and the coefficient of thermal expansion. Now it is you can see that it is given fixed at both ends. So you can directly apply the equation E is equal to E alpha delta T. This is your thermal stress concept. So you can directly apply, the value is E alpha delta T. Option C is correct. Now this is a question. It is given A rod of length L having cross-section area A is subjected to a tensile force P as shown in figure. So here it is given a force P. If the Young modulus of varies from E1 to E2 along the length, means here it is E1, here it is E2, then it is asked the normal stress developed in the bar. So first of all, the stress developed in the bar is, here you can directly say, because stress is not a stress, it doesn't come with the, so you know sigma is equal to P by A. So here anything not coming of the material property, not material property. So you can directly say the area of the cross section will be responsible and your force is responsible for the stress. Now if I talked about strain, then strain will be a material property, because you can see that sigma is equal to epsilon is equal to sigma by E. So this can be a material property, but this is not a material property. So what you can get is your question number 7, that what I am asking. So it is P by A only, because here the area of cross section is A, here also the area of cross section is A. If this is changed, then you can say, suppose this is your bar, then it will be different value. Here the area of cross section is A, here the area of cross section is suppose A by 2. Then your value will be changed for the stress, but here the area of cross section is same, hence your stress will be same on the both the sides, and it is P by A. Now if talked about strain, then strain will be different. You can then, because it is divided by the Young modulus of elasticity. So here Young modulus of elasticity is different, here Young modulus of elasticity is different. So the strain will be different. Okay. Now the next question is, a uniform circular rod of length L and area cross section A has modulus of elasticity E and coefficient of thermal expansion alpha. One rod is fixed and other rod is free. Now again the same question. Here I am just thermal stresses. You can get to see how the variation is. One rod is fixed and the other rod is free. If the temperature of the rod is increased by delta T, then what will happen? So you can just reply, because one portion is fixed and other is free. Again no thermal stresses will be there. No thermal stresses will be there. So first of all, what you can say, the thermal stress will be 0. And what is the strain? You can strain delta L is equal to L alpha delta T. So your strain is delta L by L, that is epsilon is equal to alpha delta T. So which option is correct? Stress developed is 0 and strain is equal to alpha delta T. So the option A is stress. First of all, it is wrong, because stress is not in the bar. Second, strain is there, but it is saying 0, so this option is wrong. This option is correct, because it is saying stress is 0 but strain developed is alpha delta T. Okay. Now in next question, it is given a metallic rod of length 500 mm and 50 mm diameter, when subjected to a tensile force of 100 kN at the ends, experiences an increase in length of this and a reduction in diameter, the Poisson ratio of the material. So this is a very simple question. You can just remember Poisson's ratio formula, minus delta D by D upon delta L by L. That is lateral strain upon longitudinal strain. So what is the change in diameter? Your change in diameter is 0.015 divided by your original diameter, that is 50 mm, divided by your change in length, that is 0.5 mm, divided by your original length 500 mm. So if you solve this value, your answer will come around 0.3, I think 0.3. So this is your NAT type question, so the value is 0.3. Now what is the next question? A steel cube with all faces to deform has a Young modulus E, Poisson's ratio nu, and coefficient of thermal expansion E alpha. The hydrostatic stress developed within the cube when it is subjected to uniform stress delta T. So first of all, it is given a steel cube and it is free to deform, all faces to deform. Then it means it is lying just on a surface. Okay, there is no any constant, hence the thermal stress constant. When there is no any constant, the thermal stress will be 0. So the answer will be 0. The option is it. So up to this, anyone has any doubt? Just reply me, so I am getting next page. Hello, am I audible? Hello, is it okay?
Sir,
Yeah.
can you also explain some civil engineering point of view questions?
So if you just go, concept doesn't change. It is from mechanical or it is from civil. I had the mechanical previous year book, so I taken the mechanical. If you go with civil, the same question will arise because the concept doesn't change. Na? Concept is stress is equal to strain into angular modulus. The question will come from it only. If you are getting different question from it, then I am going to discuss stress, then your Mohr circle, that is also in your civil engineering course, then SFD BMD also it is in your course, your bending stress is there, torsion is there. So I have every question, sets of questions. So I have just the constraint is I have the means book of mechanical engineering, so I'm taking it from there. But the concept, if you get any question that is other from the concept, just mail me on mail ID. I will get it to you. Okay. And if anyone has any different question sets, please send the photo to me. In the next class, in the coming Sunday, I will discuss that question also. If that is different from mechanical engineering, means question that is different, because I am thinking that if the concept is same, that question formation will be same almost. Don't think that it is from mechanical, it is from civil, because when the concept is in the variation can be covered in the, because it is a 30-year mechanical course of a 30-year gate course. So you can see the question that is I am discussing from around gate 92 to your recent gate papers. So is it okay? Hello.
Yes, sir.
Okay, so if any problem, then just mail me that photo, sir. This portion is not covered in the syllabus, so I will just discuss in the next class. Okay, so before Saturday, I request everyone before Saturday, if in civil engineering any concept is held and not been discussed, please mail me. Okay, you know my mail ID. Okay, you can just get it alek@isc.ac.in. You can just mail it, sir. This portion is not discussed in the class. Please discuss it. So I will discuss in next class. Don't worry about it. But the concept will remain same. So I am going with the next question. The 11th question is, the stress strain curve for mild steel is given as shown in figure. Choose the correct option. So I discussed this in your class. So what it is given is, what is P, R, S, T and U. What is the value? So first of all, you can see this is upper yield point because it at the top portion, so it is upper yield point. This is lower yield point. This is your ultimate strength. This is your fracture point. Okay. Now what is the point P? What here is point P is given. No, point P and point Q also. So you know the lower point is your elastic proportional point, and your upper point is Q is elastic point that I discussed. I hope you remember. So if I draw this, okay, and I take that part, so this is a portion. So this is given P, this is given Q, this is given R, S, T, and now it is U. So your P is proportional point that I discussed, proportional point, yeah, proportional limit, sorry. Your Q is elastic limit. Your R is yield upper yield point, and your S is lower yield point, Your T is ultimate strength. Okay. Now your U is fracture strength. So I hope now you can get the answer. Your P is your proportional limit. So your P is 3. Your Q is elastic limit. So elastic limit is 4. Your R is upper yield point. So upper yield point is 1. S is your lower yield point. So it is 5. Your T is ultimate strength. So it is 2. And here U that you can see, that is a fracture strength, and that is where it is given 6. So this option is correct. 3, 4, 1, 5, 2, 6. So your option C is correct. Okay. If the Poisson's ratio of an elastic material, I am going with next question, this question. If the Poisson's ratio of an elastic material is 0.4, the modulus of rigidity to Young modulus is. So first of all, remember the formula 2C 1 plus mu. Then what is the equation is asking? modulus of rigidity, that is C by E. So if you write C by E, then the value is 1 upon 2 1 plus mu. So what is the value of mu is 0.4. So if we write it, C by E is equal to 0.4, that is 1.4, and it is 1 divided by 2.8. Okay, so your value is coming 0.36. So you can directly put it here 0.36. Now the next question will be here. Sorry, I didn't click it right. So the next question is a rod is subjected to a uniaxial load within linear elastic limit. So why it is given linear elastic limit? So you can apply the Hooke's law. When the change in stress is 200 megapascal, the change in strain is 0.001. If the Poisson's ratio is given 0.3, then modulus of elasticity is. So what is the meaning of this question? So let me erase this. So the question is asking your change in stress, that is delta sigma, is equal to 200 megapascal, and corresponding to that the change in strain is 0.001, and it is given the Poisson's ratio is 0.3. Then what is the modulus of rigidity? Modulus of rigidity we have to ask. So that is C we need to find. So first of all, find E. That you can obtain this delta sigma by delta E. Okay. Now what is the value? This is 200 divided by 0.001. So if you take this, it is 10 to the power 3 in upside, and it will be 1. So this is 200 gigapascal. Okay. Now it is said that find the modulus of rigidity. So you know the formula 2C1 plus mu, and your mu is given. So if you put it, it is 200 GPa. It is 2 into 1 plus mu, that is 1.3 into C. That is 2.6, and if you divide this value, you can get, I am just writing the value, it is around 76.92 GPa. Okay, so the value is 76.92 GPa. Okay, now the next question is the room temperature stress strain curve of whom 4 materials are given. The material that behaves as perfectly plastic is. So I explained you earlier in the first class, the plastic material would be that without any change of stress, the strain will increase continuously. So your option C is correct. Okay. Now your option, what is the let me see. The option, this is S. The graph S is correct. So that graph S is D in D. Now name other portions. What are the other portions? So your R graph is perfectly elastic. Perfectly elastic. Your Q graph is elastoplastic with strain hardening. Okay. So where I should write? I should write here also. Let me write it here. So let me remember the other graph, because it can directly ask what are the other graphs is. So your Q is elastoplastic with strain hardening. Elastoplastic with strain hardening. So anyone who doesn't view my lecture of first of this topic, you can go with the YouTube link that I shared, and you can see that. Okay, strain hardening. Your R is perfectly elastic, sorry. Your S is perfectly plastic, and your P is, that given graph, your P is elastoplastic. So any problem up to this point? Anyone? Hello? Is it okay? Okay. So I am going with the next question. Consider the following statement. Hardness is the resistance of a material to indentation. That is right, because we just remember elastic modulus is a measure of ductility. Deflection depends on stiffness, and total area under the stress strain curve is a measure of resilience. So it is asking which of the consider the following statement, which of the following above statement are correct. So first of all, elastic modulus is a measure of ductility. It is showing, but you can say that your first of all, this thing is right. Now considering the second thing. Now elastic ductility means your elongation, but elastic modulus defines elongation up to elastic limit, na? But ductility can be up to in plastic region also. So this option is incorrect. Now it is the deflection depends on stiffness. So P is equal to K delta, where K is your stiffness and this is deflection. So you can see that the deflection depends on your stiffness. So this option is correct. So P are correct, R correct, and your S. The total area under stress and strain curve is a measure of resilience. No, that total area under stress strain curve is a measure of toughness. So here it is a measure of toughness. So the only option is correct is P and R. Now what is the area under resilience? So if you consider the resilience, the area up to elastic limit is called the, if you consider this is your stress strain curve, so up to elastic limit the area under stress strain curve is called resilience. So this is your resilience, and if you consider the whole graph, suppose the whole graph, then it is called toughness. So just I explained you the difference between toughness and resilience. So now what is the next question is, the Poisson's ratio for a perfectly incompressible linear elastic material. So what is the meaning of that? Incompressible means that change in volume is 0, delta V is 0. Now remember the formula that I made you to remember. Delta V by V is equal to your 3 sigma by E 1 minus 2 mu. So if remember that if you have a stress and your delta V is 0, so this term need to be 0 to get the total value of 0. So 1 minus 2 mu is equal to 0, then mu is equal to 0.5, that is 1 by 2. So the value should be 0.5. Okay. Now next question, in an engineering stress strain curve for the mild steel, the ultimate tensile strength refers to the, you can see the graph, what is the meaning of that. So this is your graph for mild steel. So this is your ultimate tensile strength, and this corresponds to the maximum stress. So you can say that this corresponds to the maximum stress. Now question number 19, a steel bar is held by two supports as shown in figure and is subjected to increase in temperature of 100 degrees Celsius. It is given your alpha value and E value. The magnitude of the thermal stress is, so you can directly apply sigma is equal to E alpha delta T. So your E is 200 GPa, that is 243 megapascal. Your alpha is 11 into 10 to the power minus 6 into delta T is 100. So the value that will come is, okay, I am just calculating 200 megapascal, 220 megapascal, okay, 220 megapascal. So the answer is 220. So your next question will be, okay, it is direct question. You can see that this is a direct question, and in production engineering this is asked. What is the value relation between E and G? So you can directly go with the option D. Okay. Now in the linearly hardening plastic material, the true stress beyond initial yielding is, okay. Now you can go with a linearly hardening plastic material. So it is like this. I just explained you. This is like this. So increases the true stress increases linearly with the true strain. So you can see that this is happening. Okay. Now your question, just I am saying, yeah. So you can see that the stress is increasing with the strain. So your option A would be correct. Now it is given, next question, the length, the width and thickness of a plate are these things. The material of elasticity is given, yield stress is given, and Poisson's ratio is given. Your the question is obtain the increase in volume. Okay, so it is given for the plate, Young modulus is given, yield stress is given, and the plate is subjected to a 70 megapascal is longitudinal stress. Okay, now the stress is given in one direction or two. Let me see. It is given only in one direction, means the diagram would be okay. I will solve it here. Let's change the pen. So your question is given. Suppose this is your 3-dimension block. Okay, and it is given your each dimensions is given, and then it is means what is the change in delta V. So first of all, remember this formula: sigma x plus sigma y plus sigma z upon E 1 minus 2 mu. So your sigma y and sigma z is 0, and your sigma x is given 70 megapascal. So let me put 70 megapascal divided by E. The value of E is your 70 gigapascal, that is 70 10 to the power 3 megapascal. 1 minus 0.66, that is your delta V by V. Now your V value is L into B into H. So you can directly obtain delta V, and that is okay. Now you can obtain delta V, and that is your the option answer is, I am calculating, uh, 1632 mm cube. So your option is 1632 mm cube. Now the next question is, up to here any problem with anyone? Hello, hello, is it okay? Are you audible? Okay, so I just for feedback, if this is okay to you, or I will discuss something else. Previous year gate questions is okay because it boosts your confidence, because solving questions in gate is not very difficult, but handling the pressure at that point in the gate examination is difficult. So going with the questions and discussing the concept, is it okay? Can anyone unmute and say? Is it okay, or I should go with the theory, that earlier thing that I used to discuss? Hello, can anyone say? I should discuss the questions or go with the theory portion? Am I audible, or no one is responding? Please someone respond so that I can proceed. Okay, write in chat box also. You can write there also. This is okay. This type of discussing the concept is okay, or going with the discussing the concept in a separate just theory portions. You can write in chat box also. Please write in chat box, because that okay. Theory means you don't want to discuss the concept, means questions. Okay. So Can we just over the stress portion? Then we will go with the theory portion. Then I will discuss the Euler buckling load. So is it okay? I will first complete the stress portion. Okay. So concept with the questions is good. Someone is saying. Okay. So, now I will just complete the stress portion. So it is given a solid cube of side 1 meter in is kept in a room temperature. Your temperature is given means 32 degrees Celsius, and coefficient of thermal expansion is given, and your bulk modulus is given. If the cube is constrained all around and heated uniformly to 42 degrees Celsius, then the magnitude of the volumetric stress is, means you can say volumetric stress, that asking induced due to heating is. So I am just giving you 1 minute to think about what is the meaning of that. So first of all, it is given, so you know delta L by L, that is L alpha delta T. You know this is for the linear strain, but when you consider the volumetric strain, then your delta L, that is this is in linear direction, so this will multiplied with 3. I hope you remember your 11th or 12th concept. In that time the delta V by V would be 3 alpha delta T. Okay, from all the directions the strain would be there, so delta V by V is 3 alpha delta T. That is your volumetric strain. Now if you just multiply, suppose you got the delta V by V and you need to obtain the stress, then you need to multiply with the bulk modulus, or in here it is written K, I am writing it like K. Then it will give you the mean stress, volumetric mean stress. Okay, so first of all obtain the delta V by V. So your delta V by V is 3 into your alpha is given 1 into 10 to the power minus 5 into delta T 42 42 minus 32, that is 10, into K. Value of K is given 200 gigapascal, that 210 to the power 3 divided by your volume, that is 1 meter cube, that is your 100 or 1000 raised to the power 3, that is will be your sigma mean. So the direct answer will be 60 megapascal if you solve this. Now the next question is, consider a linearly elastic thin sheet of material subjected to uniform axial stress along the length directions and your Poisson ratio is given. Then it is called the principal strain we need to find. So your first of all, what is this question will be come in strain Rosette, so I will not discuss here. First where I discuss strain Rosette, then I will discuss this question. Your next question is given, determine the temperature rise necessary to induce buckling in a 1 meter long rod of diameter 40 mm. Assume the rod is pinned at its ends and coefficient of thermal expansion is this. So this is again the concept of buckling, so Euler's buckling. So I will discuss first Euler buckling, then I will introduce this concept. And in next questions, in the below figure, it is given a rigid bar hinged at A is supported in a horizontal position by 2 vertical steel bars. Neglect the weight of the beam. The tension T1 and T2 is. So first of all, I just discussed in the second lecture probably. This is a problem of indeterminate beams. So what you need to do is take P, that is equal to T1 plus T2. So how do we obtain T1 and T2 in a separate way? So the second thing is, it is given that the rod is in horizontal direction, but it doesn't mean that after the elongation it will be in horizontal direction. So what we need to do is we need to just we need to just take the moment about A, because it is pinned, so it will just go like this. Okay, the rod will be go like this. So here your elongation, suppose delta L1A, here the elongation is delta L2A. So your common angle means your common angle with this common angle will be equal. That means if you take tan alpha, then tan alpha will be delta L1 by A, that is this distance. So delta L1 by A, this is your triangle, and this is equal to delta L2, this is your deflection, divided by A plus B, B, delta L2 by B. Now you know delta L1 how to obtain with the T1 relation, and delta L2 you know how to obtain with T2 relation. So the value is, so I am just equating it, delta L1, and your length is initially equals, I think, yeah, it is equal. So delta L1 upon L1A is equal to delta L2 upon L into B. Now this is your strain, and this is equal to sigma upon EA, that is equal to at one point is equal to sigma 2 upon EB. Now sigma 1 it is given T1 by area, and now area is both constant, so it will be T1 by A is equal to T2 by B. Okay, now the first is T1 is equal to A T2 by B. Now we are going to put that equation in this the pressure in this form, or actually no, this is not equal, because here the reaction force is happening. You can take the moment about this. So the moment about this is P into L, that is equal to T2 into B. So this is equal to T2 is equal to P into L by B. Okay, this is your first option, and also here one more thing is come, plus T1 into A. So this will be, let me write it here, P into L is equal to T2 into B plus T1 into A. Now we know T1 is equal to A T2 by B. So if you put the value T2 by B plus T1 A square by B, so if we write PL is equal to T2 B square plus T2 A square by B. So your T2 value is PLB upon A square plus B square. So this is T2, and if you write T1, then it will be PLA upon A square plus B square, T1. So this is your value, T1 is PAL upon A square plus B square, and your T2 is PBL upon A square plus B square. So this is your question of indeterminate problems. So you can just equate the moment about all the forces. So this is not right, you can write moment equal, and you can also write that deflection equal. The next question is 200 by 100 by 50 steel block is subjected to a hydrostatic pressure of 15 megapascal. The Young modulus and Poisson's ratio are given. The change in volume of the block we need to find. So first the same question is, you can directly write delta. So it is given hydrostatic pressure. What is the meaning of hydrostatic pressure? So it is coming under the bulk modulus concept. Here the bulk modulus, your B, that is bulk modulus, is delta P upon delta V by V. So that delta V is hydrostatic pressure. Okay, so your delta P is given, and now you need to find B. So your value is Young modulus of elasticity is given. So use the formula 3B 1 minus 2 mu. Use this formula to obtain the value of B. Put it in the equation. You get the value of B. You get value of delta P, and you also know the volume, so you can get delta V. So the answer for this question is 90 mm cube. The next question is, I just discussed this question in the class, so I am not going to discuss it. This type of question, take the elemental. So just I am refreshing the concept. Take this elemental strip, take this elemental strip, and take this elemental. So it is 50 kilonewton. So here also 50 kilonewton. Now here its force is 200 kilonewton in this direction. So it need to be 150 in this direction. Otherwise that will not balance. So 150 plus 50, 200 in this direction. So here 150 also. So here it is 150. Now here it is 250. So we need to maintain 100 kilonewton also here. So here also 100 kilonewton. Now obtain the using the principle of superposition. You can just take every deflection delta L1, delta L2 and delta L3 and sum up these three terms to get the deflection. So I discussed in the class, I am not going to discuss here. Now in the next question, question number 5. A steel bar of 40 mm and 40 mm square cross section is subjected to an axial compressive load. If the length of the bar is given and E given, the decrement in the bar. So this is a simple concept. This concept you need to use. Your bar is given, the compressive force is applied, so change in stress. So you know the stress is P by A. So your P is 200 into 10 raised to the power 3 divided by area. So 40 by 40. This is your stress, compressive stress. Your E is given 200 gigapascal. So you can obtain the strain in the direction, and strain is equal to delta L by L. So your L is given, you multiply with epsilon, delta L is equal to epsilon into L. So this is your change in increment. So the answer is, I am going to just tell the answer direct. The answer is 1.25 mm. Now the in next question it is given a bar having a cross section of area of 700 mm square is subject to axial load. The value of the twist stress in the segment BC. So I just want to remember you the concept of the principle of superposition. Divide the whole body in three parts, then equate the state of equilibrium for each part, and then you can obtain in the segment BC what is the stress. Okay. The in next question it is given a solid steel cube constrained on all sides. The temperature rises by delta T. Everything is given. The stress developed in the heating is. So I just discussed it in the 1 mark question. So first of all, delta V by V is equal to 3 alpha delta T. That is 3 times the length. Okay, because it is a steel cube, so you can say that L alpha delta T from each side. So you can just put L alpha delta T and sum up these 3 alpha delta T, that is a change in volume. Okay, now what is given? Stress you need to find. So you know delta V by V. So and you want to know the bulk modulus. So bulk modulus is E by 3 1 minus 2 mu. That is in the terms of E and mu. Now you want to obtain the thermal stress, that is would be volumetric stress. So that would be delta P by delta V by V is equal to B. So you put that equation, you multiply with it, you get let me write somewhere else. So delta V by V, you know 3 alpha delta T. Your B is E by 3 1 minus 2 mu. So the value of your stress is delta P by delta V by V is your bulk modulus. So delta P is equal to, you multiply these two terms, your B is E by 3 1 minus 2 mu into your B value, 3 alpha delta T. So the option is 3 alpha E delta T upon 3 1 minus 2 mu. So the option, I think the option A is coming correct. Let me see. Yeah, in question 7 the option A is correct. Okay. And in the next question it is given a 200 mm long stress free rod at room temperature is held in between two immobile rigid walls. The temperature of the rod is uniformly reached by 250 degrees Celsius and everything is given. You need to obtain the longitudinal stress. So the right formula is, you know, that the longitudinal stress formula, sigma is equal to E alpha delta T. Use this directly to obtain the stress. So I am writing what is the answer. Answer is 500 megapascal. Now your what is question 18 is here. Oh, if this will come. Let me do this. Okay. Now your question. This is your. Now okay, I got it. Up to here, this is for the simple stresses. Now I am going with the Mohr circle. It is a complex stresses, and these are the Mohr circles problem. So just like someone said, discuss the concept then question. So I am going to discuss the concept, revise the concept of Mohr circle. Then I will going with the questions of the previous year gate. So this will be helpful, I think. Any problem for the person who is there? Is it okay? So what I am going to do is I will revise the concept of Mohr circle. Then I will come with the question. These are very few questions. So your 30 years questions from the complex stresses and simple stresses will be revised. These are the previous year questions. Is it okay to everyone? Hello? Okay. So what? Just first of all, a revision to the revision to your Mohr circle. So first of all, why Mohr circle? Mohr circle. So Mohr circle is for where we have unlike stresses. Unlike stresses are your, suppose you have normal and shear stress. Now these two stresses are unlike stresses. You cannot directly add up or sum up. You need a concept that you will utilize to find the resultant. So that concept is be defined by Mohr circle. And what is the meaning of that? Suppose you have a body. Okay, I know I discussed these things in the class. So why I'm discussing it, because this will help you in solving the question. So I'm discussing it. This is your sigma 1. This is your sigma 2. You have a shear stress tau 1 here. Okay, so complementary stress will be present in every direction, tau 1, tau 1. Now you need to draw the Mohr circle for this. Here also sigma 2 here and sigma 1 here. So what you need to do is plot the points. So first of all, what is sigma 1? Suppose sigma 1 is greater than sigma 2. Let us suppose this. So let us take, you have a sigma 2, you have a sigma 1 comma 0 here, and you have a sigma 2 comma 0 here. Now your tau that I used to discuss, you remember, I think clockwise direction is positive. Clockwise direction is positive. So here sigma 2 direction is positive, but here sigma 1 direction is negative. Means this tau is going here, but at this direction is positive. So at this point, draw a line vertically upward, and here draw a line vertically downward, because this is negative and this is positive. Now this coordinate is sigma 2 comma tau, and this coordinate is sigma 1 comma minus tau. Now what you need to do is draw a line in between. Means you draw a line in between. Okay, this is your line in between. This is the center of the circle. So let us suppose this is point O, this is point A, this is point B, this is point C, this is point C. Now this is your center of the circle, and this is your radius. Means this is your radius. This is radius, and draw a circle with respect to this. So I am going to draw a circle with respect to this. So let me draw it here and just wrap it here. So this is your circle. Now the point cutting at this point, let me change the color of the pen. Okay, now this point, this is called the minimum principal stress. Minimum principal stress. This point, if you extend this line, this is called the maximum principal stress. This is called maximum principal stress. And this point, suppose I am drawing this, and this is cutting at point, suppose Z. So at Z point, this is the coordinate is your, suppose sigma comma tau. Then the tau is tau max. Here we have the maximum shear stress, because this, you can see that this is at the topmost of the point. So this is the maximum shear stress. Now this, if we rotate this by 2 theta in the anti-clockwise direction, then this is this plane. Suppose I am writing Z double dash. Z dash Z double dash is your principal plane. And you know the definition of principal plane? Principal plane is that plane at which shear stress is 0. So you can see here and this at this plane, anywhere in the plane, your shear stress is 0. So this is your principal plane. And this is your concept of Mohr circle. Now if you need to find at any point in 2 theta direction, suppose in theta direction, you need to find the stress. What is the stress at this plane? What is the normal stress and shear stress? So what is the angle of orientation? It is coming in anti-clockwise direction in theta direction. So take here, rotate anti-clockwise in theta 2 theta direction. Suppose this point is coming here. Okay. Now this is the point at cutting edge. Suppose this is sigma comma t. The sigma and the t value is the corresponding normal and shear stress at this plane. So, anyone has any concept in division with Mohr circle? Is it okay? Then I am going to discuss with the concept of the Mohr circle and the questions. I discussed the concept, now I am going with the questions. So your question is, elastic body is subjected to a tensile stress x in a particular direction and compressive stress y in a perpendicular direction. X and y are unknown in magnitude. On the plane of maximum shear stress in the body, there will be, what they want to say is, suppose this is your body. So please, if you want to just do the questions for Mohr circle, please be with me. I am going to discuss what is the question is asking. So your question is, suppose you have given your sigma 1 here and compressive vertical direction sigma 2 here, and the question is asking on the plane of maximum shear stress. First draw the Mohr circle for this. So I am going to draw the Mohr circle. So this is not good. I need to take both axes. So suppose this is the diagram of Mohr circle in this point. So it is given sigma 2. So it will be coming here sigma 2 minus sigma 2 comma 0, and it is coming here sigma 1 comma 0, and it is given both are unequal in magnitude, means sigma 1 is not equal to mod of sigma 1 is not equal to mod of sigma 2, means they are unequal. Then we need to just draw the Mohr circle. So I am going to draw the Mohr circle here. So this is your Mohr circle. Okay. Now what it is asking, on the plane of maximum shear stress, what is the following condition true? So where is the maximum shear stress? So suppose this is your center. So this is your maximum shear stress plane. So at this maximum shear stress plane, you can see that there is a normal stress also. This value has some means sigma and some tau. So you can say that what is the options are correct? Yeah, both normal and shear stress both are present at this point. You can say this. So is it okay to everyone? You got this point? Hello? Hello? Is it okay? I'm not getting any response. Okay, now I'm going with the next question. Please respond fast, because I need to discuss every concept, because very few concepts in that. I need to do the some questions so that you can answer, because in the classes I had done things in very hurry. So now the next question is, a cylindrical elastic body is subjected to pure torsion about its axis. Now what it is given? Pure torsion. So I just suppose you have a body. You take this element. Suppose at the body you take this element, and now this element has pure shear stress, because you know torsion has a pure shear stress. Now if you draw the Mohr circle of this, it will be a circle, just I explained you earlier, it is a circle, okay, of radius is equal to tau. Now the question is asking tensile stress in a direction 45 degree to the axis, no tensile or compressive stress, maximum shear stress along the axis of the shaft, or maximum shear stress at 45 degree to the axis. So suppose this is your axis. So if I am taking this as an axis, so here it is asking, so suppose if I am drawing anything with the direction of axis, so this is your axis, I am drawing it, and suppose this is your theta angle, or I am writing it here. So it is asking where the first option is tensile stress in a direction 45 degree to the axis. So if this is your axis, because the shear stress is acting, so this is your axis of the body. Now if you take 45 degree with the axis, so in Mohr circle everything is 2 theta. So here it is 2 into 45, that is 90 degree. So take 90 degree with the axis, then 90 degree here it will rotate like this, or it will rotate like this. So if you rotate in either direction, you are getting tensile stresses. So your option A is correct, because you are already in the direction of a shear stress and you need to find the tensile stress. So if you rotate by 45 degree, that is 2 in the direction of 45 degree to the axis, that is 90 degree in Mohr circle, you get the tensile stress. Okay, so the option A is correct. Now it is given if the two principal strains at the point are given, the maximum shear strain is. So just like it is Mohr circle for strain, I just asked you to do the question, because I discussed the Mohr circle for if you remember. So the question is saying your epsilon 1 is given 1000 into 10 to the power minus 6, and your epsilon 2 is given minus 600 into 10 to the power minus 6, and you need to obtain the maximum resistance. So let me draw the point. Your epsilon 1, sorry, here epsilon 2 is given, comma 0, and here epsilon 1 is given, comma 0. And if you draw the Mohr circle point with this point for strains, and you know it is gamma xy by 2, this is gamma xy by 2, this is epsilon, I hope you remember. Then it is obtaining maximum shear strain. So you know this is the radius of the circle is the maximum shear strain by 2. This is gamma max by 2. Now gamma max by 2 is the radius of the circle. Now what is the radius of the circle? Epsilon 1 minus epsilon 2 by 2, that is equal to 1000 minus 600 divided by 2. So the value is 800 into 10 raised to the power minus 6. That is the value of gamma xy by 2 maximum. Now what is the value of gamma xy maximum? Multiplied by 2, that is 1600. So the option is C, 1600 10 to the power minus 6. Okay, so I hope everyone is clear with this. Now what is the next question is, the figure shows the state of stress at a certain point in the body, the magnitude is given, you need to find the radius of the Mohr circle. So the radius of the Mohr circle, I just explained it, it is sigma x minus sigma y by 2. So what is given? 100 minus 20 divided by 2, that is 80 divided by 2, that is 40. So your option is 40. If the principal stresses in a plane stress problem are sigma 1 and sigma 2 given, maximum shear stress, just now I discussed, it is the maximum shear stress is radius of the circle, and radius is equal to sigma x minus sigma y by 2, that is equal to 100 minus 40 divided by 2, that is equal to 30. So your option is 30. Here it is given sigma x, sigma y and tau xy, then find the radius of the circle. So I hope you remember, it is a complex state problem, that is sigma 1 is given, sigma 2 is given, and your tau is given. So at this point the radius of the circle is, I hope you remember, if not then please review the lecture, sigma x minus sigma y by 2 whole square plus tau xy whole square. This is your radius of the circle, and radius of the circle is the Mohr circle. So if you put the value, sigma x is equal to 200, sigma y is equal to 100, and tau xy is equal to 100. You put these things in the value, so you will get under root of 50 square plus 100 square, and the answer is, I think it is question 6. Your answer is 1118.8 megapascal. So up to this point, anyone has any doubt up to question number 6? So please respond. Don't make me to ask. Anyone has any doubt? Any suggestions? I need to do more with the complex stress problem. Please respond in message also, because the more late you respond, the more time you will get lost in the just asking the question. Okay, so so the person who responded, so I'm asking you, is this format okay? First discuss the concept, then the question. Is this okay? Yes, okay. Okay, I am going with it. So your option is 118.8 megapascal. Now your next question is, in a thin plate of uniform thickness is subject to a pressure as shown in figure under the assumption of plane stress which are the following stresses. It is given stress in one direction, a thin plate of uniform thickness is subject to, and you need to find at this plane. So if you think of this plane, you have only one stress that is coming in the sigma y direction, that is some value, but sigma z direction it is 0. So we can say that normal stress is 0 in sigma z direction, because if you take this plane, you can see that only the stress is coming is around the y direction. So you can say that along the z direction sigma z is 0. Now in the next question, if the principal stress values are 120 megapascal, minus 50 megapascal and 10 megapascal, then the maximum shear stress is. So I hope everyone remembers what I discussed in the last class. So this is a good question to clear the concept. So suppose this is your value. This is your stress problem. So it is given, first of all it is 120, a value is 120, 0. Your second problem is minus 50, 0, and your third problem is 10, 0. These are the three principles. Now we can draw three Mohr circles from these 3 points. So let me draw the Mohr circle. So first Mohr circle will be in between these two. So let me compress this. Okay, this is the first Mohr circle. Now the second Mohr circle is in between these two. You can draw 3 Mohr circles. So I am drawing the third Mohr circle. Okay, this is your second Mohr circle, and the third Mohr circle will be in minus 50 and in 120. So if I take this, this is your third Mohr circle. Now in the question it is asking maximum shear stress. Now you know this is your first let us suppose this is Mohr circle 1, this is Mohr circle 2, and this is Mohr circle 3. Now you know the maximum shear stress is the radius of the Mohr circle. So which circle has the maximum radius? So you can think of this radius because it's a biggest circle. So this circle has the maximum radius, and its value is, you know, max radius is equal to sigma x minus sigma y by 2, that is equal to 120 minus 50 divided by 2. So that is 170 divided by 2, and you can write it as 170 divided by 2, what it will be, 65 I think. No, 85, sorry, 85. So this is question number 789. Yeah, the value is, let me see, 85, question number 8, it is 85. Now your next question is, a shaft with circular cross section is subjected to a pure twisting moment the ratio of the maximum shear stress to the largest principal stresses. So first of all, this is a condition of pure twisting moment. So pure twisting moment, the Mohr circle will be just a circle, okay, and it is given maximum shear stress. The value is maximum shear stress is radius of the circle, that is tau, and your largest principal stress is also tau. So your ratio for that is 1, because tau divided by tau would be 1. So the option is option B. Here I think the question is not coming, so I'm going to discuss next question. Next question is the state of stress at a point is this, and you have given, you listen, this is a question of pure shear stress. You can see that pure shear stress means this is a question of pure shear stress, and it is given the maximum stress in megapascal at that point. So you know the maximum normal stress is, if you drop for pure shear stress, it is a circle, so maximum normal stress is just the value, so it is 50 megapascal. Okay, now the some value is given, sigma xx, sigma yy is given, and tau xy, that is S, the Mohr circle of the stresses. So I want everyone to please, what is the value? Just is a good question. You can say this is a very conceptual question. So let me put it here. The question is given, you have a body that has sigma x here also, sigma x here also, and you have the value of tau x like this. Now you need to find the Mohr. First of all, draw the Mohr circle. So let me draw this Mohr circle. You have given sigma x as sigma x equal, so these 2 points will coincide, means this is also sigma x comma 0, this is also sigma x comma 0 for both the things, for this also, for this also, because both values are equal. Now this is coming in clockwise direction and this is coming in anti-clockwise direction, so one will go up, sigma x comma tau, and one will go down, sigma x comma minus tau. Okay, now you need to draw the Mohr circle for this. So if you draw the Mohr circle, this is your Mohr circle. It is asking the center is at, the center of course the center is at sigma x comma 0. So this is sigma x value is S, so it is S comma 0, and its radius is also S, because the value of tau, the radius is value of tau, and tau is also S. So radius is the value of tau, and tau is also S. So the option that is coming, that is correct, is option A. Is it okay to everyone? Okay, I am going with the next question. If sigma 1 and sigma 3 are algebraically largest and smallest stress, so maximum shear, so that's the same thing. The radius of the circle is the maximum shear stress, and that is value is sigma 1 minus sigma 3 by 2. So your option B is correct. The stress of a point in a component is represented by Mohr circle centered at 200 megapascal, and its radius is given 100 megapascal on the normal stress axis. On a plane passing through the point, the normal stress is 260 megapascal. So at this point, we need to find the shear stress. So let me draw the what question is saying. Let me explain you. So suppose you have a given a Mohr circle that is centered at 100, 0 megapascal, and its radius is 200 megapascal. So let me draw a circle. Oh, sorry. This is your circle. If I take this, okay, this is your circle, and oh, wait, circle is wrong. So this is your circle. It is given the center is at this point, okay, and the radius is given 200 megapascal. Now at the point where the normal stress is 260 megapascal, suppose if I draw line this, and it is suppose the normal stress is 260 megapascal. Then you need to find the shear stress at this point. Now how we can find it? So first of all, consider this triangle. So let me change the pen. Okay. Okay. Now consider this triangle. Okay. You have given the radius, and the radius is 200. It is given 100. Up to this location it is given 100, and here you have given the value is 260, means you have given the value as 260. Now to obtain this value, the base of the triangle, you subtract both the values, it will be 160 here. You know the radius, you know the base of the triangle, so you can find height using the Pythagoras theorem, that is 200 square is equal to 160 square plus h square, and the value that will come is, okay, the value that is coming is the radius is what is the question? Oh, sorry, just I put in a different way. Okay, the value can be same if just change it. I'm just changing the question slight a bit. So it is given 200 megapascal, it is given 100 megapascal. Now it is okay, and the value that is coming is 200 square minus 160 square whole root. You can solve it. The value is 200 square minus 160 square root of answer 120. The value would come in 120 megapascal. Okay. Now the next question. Okay. So the next question is, let me erase this everything. Up to this, anyone has any problem? Please ask me. So I'm moving ahead. Please someone respond. I can't see the chat box. Hello. Is it okay? Okay. Just assuming everything is okay because no one is responding. So this is given a stress and its value is, so it is a stress tensor. Now why I just putting the question, because the thing that hasn't been discussed I am going to discuss is here. So stress tensor, if you draw for a state of the body, so I am writing it, this is the standard condition, sigma xx, sigma xy, sigma xz, sigma yx, sigma yy, sigma yz, sigma zx, sigma zy, sigma zz. So wherever the coefficient are same, means both coefficient are same, that is called the normal stress, and where the coefficient are different, that is called the shear stress. So here if you just reduce the stress tensor, it will be sigma xx, tau xy, tau xz, tau yx, sigma yy, tau yz, sigma tau zx, tau zy, and sigma zz. So you can see that at the diagonal the elements are the normal stress, and at the rest of the point the elements are the shear stress. So moving along this direction, along the columns, you can say the x is constant and y is changing, and along the y the value of, means you can say this here at one particular direction it is x, it is in y, it is in z direction. So if you consider this particular thing with this graph, it is asked what is the shear stress in the xy plane. So in xy plane, what is the shear stress? Tau xy. So obtain what second position? Second position is this 10 megapascal. So the answer is 10 means mega Newton per meter square, that is 10 megapascal. So stress tensor is okay to everyone? Hello. Yeah, please don't write in chat box, sir. I have need to come again and again to see the chat box. It is not Zoom, so please respond. Now So same with the stress tensor, let me draw the strain tensor. So I am going to draw the strain tensor. And strain tensor for a particular body is epsilon xx, and with this point you have a shear stress. The corresponding deflection will be gamma xy by 2. Remember the Mohr circle, how we replace it. It is gamma xz by 2. Here it is gamma yx by 2. Here it is epsilon yy. Here it is gamma yz by 2. It is gamma zx by 2, gamma zy by 2, and epsilon zz. So this is your strain tensor. So this is your normal strains and this is your shear strains. Okay. So if someone is given in this format and your center value is 0.001, and you need to ask what is the strain in xy direction, so just multiply it with 2, because here the value is gamma xy by 2. So if you want to know the gamma, multiplied by 2 so that you can get the shear strain in the direction. Now just few questions, only 3 pages. So at a point in a stress, it is given 45 degree apart as shown in figure. Determine the two normal stresses. So what is given is, you can see the question. So if I was to draw that, let me draw this here. Okay. Let me put it here only. So it is given your two planes, one is at 8 megapascal and shear is at 3 megapascal, and here it is given the at 45 degree plane, and you need to obtain what is the two normal stresses. So how we'll do that? Suppose you have given first of all 8 megapascal and 3 megapascal, that is in anti-clockwise direction, that will come down, and so for that I think I will discuss this in next class, because this is a little bit tricky problem. I just need another time, or let us discuss whatever it is. So first of all, let me discuss one thing. Okay, suppose you have sigma xy, take it here, and you draw the Mohr circle with it, and at any angle 2 theta, what is the value of tau and that value? So I am going to discuss first that. So I am going to write it directly. So your sigma at any plane theta is sigma x plus sigma y by 2. That is the value of your means we can say that this is the value from this point to the center, then plus sigma x plus sigma y by minus y by 2, that is your radius. Oh, it is getting very complex, so let me write it here. So for any Mohr circle with 2 points and a shear stress, if you draw it, and at any angle theta, 2 theta, you have given sigma and tau, then sigma at any angle theta, please remember this formula, sigma x plus sigma y by 2, this is your from at this point what is the centered position, plus sigma x minus sigma y by 2, this is your radius, not radius, this is the centered position, this is your you can say that at this position, this is called the into cos 2 theta minus tau xy sin 2 theta. So this is your standard formula. Use this formula. We can derive this from the Mohr circle, but I want you to remember this. Okay. Now this question is given. At this point you have given the normal stress, and you know for this plane you have the normal stress and the shear stress. So if you put the value in this equation, you can get the value is given 2 is equal to 8 plus sigma y by 2 plus 8 minus sigma y by 2 into cos 45 degree it is given, so it will be 90 minus tau xy, that is 3 into sine 90. So if you solve, you get sigma y is equal to 2 megapascal. Now you can draw the Mohr circle and you can obtain the principal stresses for this problem. Okay, you know, and now you know also this point has sigma y is equal to 2 megapascal. So now you can draw a Mohr circle with this and you can find. So any doubt in this question? Okay, in the next problem, a pure shaft is subjected to torsion, experience a pure shear stress, the maximum value of shear principal stress. So the same problem that I discussed earlier. So if a pure shear stress condition, it will be a circle and this is your plane of the body and it is given 45 degree to the axis. So it means 90 degree turning with the axis. So this is your axis line. If you turn it, then this value is also tau. Maximum principal stress on the surface which is 45 degree to the axis with a value. So if you just write it, you can solve this 2 into tau into sine 45 is 1 by root 2 and cos 45 is also 1 by root 2. So if you cut that, it will be value of tau. So maximum principal stress will be tau. Okay, the option D is correct. Now next question is given, the state of a stress of a point in 2-dimensional loading is such that the center is given at this point. The state of a stress at the point in a 2-dimensional loading is given, center is located, and you need to find the maximum principal. And so why question is given, if you have circles at 2 different locations, you know the value, then you can subtract it and divide by 2, you can get the radius. Okay, or just suppose this is your sigma 1, this is your sigma 2. So your radius will be, first of all, sigma 1 minus sigma 2 by 2, this is your radius. So this is your radius. Okay, if you subtract, so your and if you want to find out the location of the center from this radius, you just add it in between sigma 1. So the value is your sigma 2 minus sigma 1. Your value is sigma 2 plus sigma 1 by 2. So if you just put this value here, sigma 2 plus sigma 1, so when 175 will come, the value should be, just if I put it like this, 175 by 2 or 175 megapascal, the answer is B. Your answer is B, because if you just put sigma x plus sigma y by 2, this is your center location. So 175 plus 175 divided by 2, that is 175, your center location is 175. So you need to find in that way. So the next question is, the Mohr circle for a stressless body is shown in this figure. Okay, you need to find the maximum shear stress. The design is to be done on the basis of the maximum shear stress theory, and the yielding will just begin in the design to the ductile material whose yield strength is. So you need to find the maximum shear stress. So for that, the maximum shear stress would be the radius. So what is the radius? You know the radius is sigma x minus sigma y by 2. So that value is minus 100 plus 10 divided by 2. That will be equal to 45 megapascal. So the value is 45 megapascal. Now the next question is, a solid circular shaft of diameter this is given with the axial stress of this, it is further subjected to a torque, the maximum principal stress is, so it is given a solid circular shaft that is given a load P, okay, and now it is acting with a twist, torque. So you need to obtain the maximum principal stress. So first of all, with the P you obtain the stress, normal stress, that is P by A, that is 50, actually it is given, that value is directly given 50 megapascal, and your shear stress is given TR by J. I hope torsion everyone remembers TR by J. So torque is given 10, that is into 10 to the power 6, because in kilonewton you convert 10 to the power 3 and in meter you convert mm. Into r, what is the value of radius? The value of radius is 50 divided by j, pi by 32, d raised to the power 4, 100 raised to the power 4. So you get the value of torque as 50.95 megapascal. Now draw the Mohr circle for that. You have a given one value is 0, other value is 50, and it is 50.96, it is 50.96 negative. And if you draw the Mohr circle, you need to find this value. What is the value of this? So this is your center, and if you take the value from the center, so what is your value of center is, suppose this is 50, so this is 25, 0, and this is your radius, and radius is under root of sigma by 2 whole square plus tau square. That is your radius, because it is sigma, if you know, and this is half, this is sigma by 2, and this is tau. So radius is sigma by 2 whole square plus tau square. You add that, you get the value of maximum principal stress, that is 82 megapascal. Okay, so anyone has any problem in it? Hello? Hello? Please respond someone that if it is it okay going with the with this speed or questions. So now next question is, because no one is responding, I don't know. So the next question is question number 10. In a plane stress condition, sigma s given, sigma y given, and tau y given, the maximum shear stress we need to find. So maximum shear stress is the radius of the circle, and you know the radius of the circle is under root of sigma x minus sigma y by 2 whole square plus tau square. Now you know sigma x, sigma y, and tau xy. Put the value. It is 50 square plus 40 square. That so it is 50 square plus 40 square. Then the value is coming around. Let me solve. The value is coming 80 minus. Oh, sorry. 80 plus 80 minus 20, that is 60 divided by 2, that is 30 square. Sorry, 80 minus 20 divided by 2, that is 60 divided by 2, 30 square. So it is 50. So your value is coming 50 megapascal. Now your question 11 is given. My screen is visible to everyone? Is it okay? Hello. Is it okay? Okay. So let me go with the question next. And it is given. You can directly solve this question because it is very easy question. A rectangular bar of rectangular cross section is pulled. So I am going to express first of all what is the stress, 100 by 50, that is 2 megapascal. This is given, and you need to draw the Mohr circle first for this. So Mohr circle is one point, it is 0, it is 2 megapascal. So if you draw this, it is like that. Now at an 45 degree with the axis. So 45 degree with the axis means 90 degree Mohr circle. So if you turn 90 degree, this is the radius of the circle. So what is the radius of the circle? 1 megapascal. So the answer is 1 megapascal. So this is your question. This is a very easy question. So the next problem is just here. Okay. So this is a good question if you want to just know something. a rectangular region in a solid state is given, the xy coordinates of given the body is given, your epsilon x epsilon y is given, gamma xy is given, the deformed length of the diagonal we need to obtain. So please hear me clear. Just suppose this is your body, rectangular body. This is one coordinate 0 0. This is coordinate 4 0. This is coordinate 0 3, and this is 4 3. This is our rectangular body. Now epsilon x has changed. That is epsilon x is equal to 0.001. Epsilon y is given 0.002, and gamma xy is given 0.003, and you need to obtain the deformed length of the diagonal. So first of all, you can use just the Mohr circle, because if you draw the Mohr circle with this diagram, you can just go with epsilon x is 0.001, so 1 here, and it is 0.002, that is 1 here. Gamma xy by 2, you know, here we can take gamma xy by 2, so one value is coming here, one value is coming here, and if you draw the Mohr circle with it, okay. Now you know the diagonal is at half angle, okay, so it is 90 degrees, so it is 45 degree, diagonal is 45 degrees. So in this this is your plane, so rotate with 40 means 90 degrees. So if you rotate here with 90 degree, what you will get is, suppose you come at here at this point, and at this point you need to find what is the value of the strain, that is E theta. So at E theta, this is your strain at 45 degree, that is you can obtain, and you multiply with the length of the diagonal to get the change in length. Okay, so first of all, what is the value? I am going to write it. This is your 0.001. This value is up to here. It is 0.002, and your tau value is 0.0015, because it is half. Now what is the radius? First of all, obtain the radius. Radius is equal to, if you just divide -1 by 2, 0.00015, sorry, 000, let me see, write it again. So 0.005 is the radius, okay. Sorry, this is at the center, this distance 0.0005, and if you just take this distance, this is 0.0015, this is square plus 0.0015 is square, and if you solve, you can get the radius. Now what the radius is, let me solve it. 0.0005 is square plus 0.0015 is square, and your answer is coming, the radius is 1.58 into 10 raised to the power -3. So this is your radius. So you can just take the suppose this is your radius 1.58, and you know this theta, you know this theta, you can minus with 180, you can get this theta. Then you project this along this axis, you can get 1.58 cos theta. You can get this value, and just add with this value, you will get the what is the elongation at the length. So if this will find you difficulty, if you ping me, we will discuss in next class. So the next question is, the state of a stress in a point is given, okay. The normal stress we need to find sigma y, and your minimum principal stress is given. So this the value is same that I discussed with you. Your minimum principal stress is given, okay, and we need to find what is the value at sigma y. So first of all, you can just you know, sigma minimum is equal to sigma x plus sigma y by 2 minus under root of the value is sigma x minus sigma y by 2 whole square plus tau square. So you can directly obtain sigma y from this equation. This is the expression for sigma minimum, and for sigma maximum your expression is sigma x plus sigma y by 2 plus under root sigma x minus sigma y by 2 whole square plus tau square. So just put sigma minimum value, x value and tau value, you can obtain sigma y value. So next question, it is easy. So I am ending the complex stress and shear stress part. So is it okay to everyone? Any doubt? I am just asking. Hello, can someone respond? Hello. Please respond in chat box. The simple stresses and complex stresses, I discussed almost all questions that came in the previous year up to 2019. So is it okay? Okay. So I know that my speed is fast because I need to discuss very much thing in very less time. So just I need to give you a rough idea. That's why I am also recording, because in any point of time I will share this PDF also. This question PDF, you can just go through it. I just discuss everything. That will be helpful at in any point of time when you require this. Okay. So this will helpful in means you can just go with it. It is just your practice question, but I am discussing. Why I am discussing? Because I know some of you are not going to solve previous year question. Now when I am here solving the previous year question, you get the time to solve the test series. So now that will improve your efficiency more than what you think. So that will help you. Because solving previous year is an important part to know the essence of gate, what they ask. So I want to ask you, any of you, do you think it is difficult to write the gate paper, or it is difficult to solve the problem? No, you can just say yes or no, or write in the chat box. Hello, you can write in the chat box. Is the previous year that I shown for the simple stresses and the complex stresses. Hello. Hello. So you can say that these are the difficult things, or you can just getting it easy. Can anyone say? I have 2 minutes, then I will start the next portion. So please respond fast. You can write in chat box also. Are you seeing the question difficult, or it is easy for you now? Hello. One minute more, because now I have to start with SFD BMD. So please respond fast. Okay, no one is responding. I don't know. So now going with the SFT BMD. So I'm going to first make you revise what is SFT BMD. First, look, what is SFT BMD? I need to revise first. So suppose you have a beam and it is supported at the ends, and you just apply load. Okay. Now what will happen? It will bend like this, something bend like this. So, but the shape of the beam that is coming. So if we just go with the internal structure, internal resisting force is coming in at any section. So if I just took this section at like this, so these two stress things are coming in the body, this is called the shear force and this is called the bending moment. This is a positive sense, means you can say these directions are the positive. Now why it is coming? Because suppose if you apply load, now if this doesn't come, then the rod will simply tear apart from the center, or it will go just like anything like this, okay, but it is resisting this force, this W. So you can say that internal shear force or the moment that is acting will tend to deform but want to save the material, that is the bending moment, that is internally developed. So these are not the external but the internal things. These forces are internally developed. So SFD shear force diagram and bending moment diagram is necessary. Why? Because you need to find at what point you have maximum shear stress and at what point you have at which location you have the maximum shear force and at which location you have the minimum shear force, and also at which location you have the maximum bending moment and also at which location you have the minimum. Why you need this? Because from maximum shear force you can obtain the maximum shear stress, and from the maximum bending moment you can obtain the maximum bending stress. So these are the two important things you need to know. Okay. That's why shear force and bending moment diagram are useful. So just a few recap of suppose you have a simply supported beam, your A, B, C 3 points in the beam, and it is at L by 2 centered. Now you need to find out what is the SFD. So first of all, take this element. This is your positive sense of direction. Okay. Now here you have reactions of W by 2. Now this is SF. Now take SF. This is in negative direction. It is coming in upward direction. So it will be minus W by 2, that is equal to 0. Now SF is W by 2 at any portion X. Now if you draw the shear simply the SFD, it is W by 2 constant up to which next load is acting. So next load is acting at B. Now take the point after B. What is the value of shear force? So if I take this as okay, this is the point after B. So it is W. It is the reaction is W by 2. Now take this point SF. Now at any distance X you can get SF plus W minus W by 2 because it is in downward direction and with this force, and it is coming in upward direction, is equal to 0. SF is minus W by 2. So after this at the point of W it is coming minus W by 2 and it is the constant same minus W by 2. So this is your shear force diagram for this simply supported beam. Now you need to draw for the what is the bending moment diagram. So take this load. This is your positive direction of bending moment M, and at any distance X, suppose this is your W by 2, at any distance X, M minus W by 2 into X is equal to 0 because it is coming in this direction and it is coming in this direction. So this is an anti-clockwise and this is a clockwise sense. So it is opposite. So M is equal to W by 2 into X. So means this is a straight line. At X equal to 0 it is 0 and X is equal to L by 2, it is WL by 2. Now after that, after X equal to W means L by 2, suppose this is W by 2, this is W, and after that if you take any position X, then what is the moment? This is your positive direction, this is M. Now this is adding up plus W into X, and now this is coming in the opposite direction because this is clockwise, this is anti-clockwise, this is anti-clockwise and this is clockwise, minus W by 2 into L by 2 plus X. And if you solve this, you get M is equal to WL by 2 minus WL by 2 into X. So this will come like this. Okay. So this is a basic recap of bending moment diagram and a shear force diagram. So I am going with the questions that came in the previous year, and these are not very large questions, or yes, you can get easy in easy way how to solve this. Okay, so first of all, the first question is, for a simply supported beam on the two ends, the for a simply supporting beam on two ends supporting the bending moment is maximum. So what is the question is, suppose you have a simply supported beam, okay, and it is supporting bending moment, suppose it is supporting bending moment or force, and it is asking where it is maximum. So suppose you have M in the whole section. So to obtain the maximum, you need to find apply the concept of maxima and minima. So the maxima and minima says, if you just derive M with respect to x and equal to 0, you get the location of x. Now you also remember that dm by dx is also shear force. I just told you dm by dx is also shear force in slope and deflection. So that means wherever the shear force is 0, you have the maximum bending moment. So the answer is, where there is no shear force, where shear force is 0, you have the maximum bending moment. So first option is this. Now it is given a block of steel is loaded by a tangential force on the top surface while the bottom surface is held rigidly. The deformation of the block is due to. So you can say that this is a take this as this is the force that is F is acting, that is called the shear, that is the one portion. Okay, that will cause the shear, but also the height is so much of this block that at this portion it will also tend to form a couple, because suppose this is your height, so a force into perpendicular distance is the couple, so that will cause a bending also in the block. So you may also see that this block deformed like in the shear direction, and also the distance is large, so it will tend to deform like a curvature. Okay, so that means it deforms in the shear as well as bending also. Now the next question is, a concentrated load P acts on a simply supported beam at a distance L by 3 from the less support. The bending moment at the point of application of load is. So what is the question is asking? Let me go with it. So the question is, suppose you have a concentrated load, this is a bend, and it is acting at a P L by 3 distance from the less support, and it is 2 L by 3 if the whole length is there. And you need to find at this point what is the bending moment. So first of all, we'll find out the reactions. Suppose this is A, this is B. So RB into L is equal to P into L by 3. So your RB is equal to P by 3 and your RA is equal to 2P by 3. First of all, the reactions are this, and then we need to find the bending moment. So suppose take any distance x. Okay, take any distance x. Suppose this is your beam, this is acting 2P by 3, and you take any distance x. This is your moment. Now M at x, any distance x is equal to 2P by 3 into x. Now at the application of load, the x is the value of x is L by 3. You put that value, x is equal to 2P L by 6. That is, sorry, 2P L by 9. 2P L by 9 is the answer. So anyone has any problem in this question? Please respond. Hello. Please respond in chat box also. Hello, anyone? I'm audible. Everything is going all right. Please respond. Okay. Okay. So the next question is, you have given a cantilever beam carries the antisymmetric load where WO is the peak load. The correct bending moment diagram is. So first of all, what is the correct bending moment diagram? Now this is 1 mark question. You need not to solve the question. So what is the correct? So first of all, your load is in the uniformly varying load. So you know the dF, that is shear force, by dx, that is the load. Okay, rate of loading, and rate of loading is the uniformly varying load, that is W naught into x. So this will come as x. Okay, now if you integrate this shear force, we get bending moment. Okay, bending moment is equal to, dm by dx is equal to shear force, and that is equal to x square by 2. So I am talking about the profile because it is only asking the profile. Now what is the bending moment? Bending moment is equal to, integrate it again, it will be x cube by 6. So anything representing the x cube format is the value for this. So the option is D, because and you can also say that this is a, because the shape you cannot explain, but anything with that represent the S cube format is your bending moment diagram. So, and the next question is, a simply supported beam PQ is loaded by a moment of 1 kN meter at the midspan of the beam. The support reaction RP and RQ is. So let me this is a mechanics question. So this is P, this is Q, and it is given 1 kN meter, and it is 1 meter, and you need to find what is reactions at P and Q. So suppose, because you know this is acting in clockwise direction, then this should act in the opposite anti-clockwise direction. So first of all, the P need should be downward so that an anti-clockwise movement can be formed. Now if we take a moment from this direction, Q into 1 is equal to 1 kN meter. So Q would be 1 kN. So here it is 1 kN and here it is also 1 kN. Okay, because this will form a couple in the anti-clockwise direction if we just solve. So the answer is, at Q it is 1 kN downward, and at P and Q it is 1 kN upward. So the reaction force at P is 1 kN, but it is in downward direction, and at Q it is 1 kN, it is in upward direction, and it is forming a couple that is in anti direction with the applied moment. The next question is, a beam is subjected to an inclined concentrated load. Neglect the weight of the beam. Choose the correct free body diagram of the beam. So first of all, what is the correct free body diagram? So let us take the support, because this is question from the support. So this is a roller support. So you know roller support produce only Y reaction, and your pin support produces X and Y both. Okay, and now this is your load. So you can think of this diagram, and wherever you are finding this is correct. So anything like B, it is showing this diagram. So you can say that the B option is correct. Okay, you can say that the B option is correct. For a loaded cantilever or uniform cross section, the bending moment is given, okay, from the free end of the beam. Magnitude of shear force you need to find. So you have given m of x, that is 5x square plus 10x, and x is from the free end, and you need to find the shear stress, shear force. So first of all, you know that dm by dx is the shear force, SF. So if you derivate it, it will be 10x plus 10, and the distance should be 10 mm from the free end. So if you put 10 mm, 10 into 10 plus 10, that is equal to 110 Newton. So the value is 110. Okay. So let me check. Yeah, it is 110. The next question is in 2 marks. Okay, let me erase this, or I should write it here. Yeah, okay. So the next question is two bars A and B connected by a frictionless hinge at B. Okay, the assembly at frictionless hinge at B. So this is a hinge only at B. The assembly supported and loaded as shown. The shear force and bending moment diagram for the combined beam AC clearly leaving the important values and sign conventions. So initially gate asked these questions because the gate is conventional in initial years in the when it is starting to head. So it is given you have a load at and hinge at B, then you have something like this at C. This is a roller support, and this is your A, B, and you need to draw the shear force and bending moment diagram. So 100 kN here and 100 here. The distance is from here it is 2 meter, it is 1 meter, and again it is 1 meter. So first of all, let's split the diagram. Why I want to split the diagram is, okay, so let us, because it is a hinge at A, only the reaction that is produced is the vertical reaction. So what I will do is, suppose this is acting in this direction, and if you just want to split the diagram, this is acting in vertical direction, and this is also acting in vertical direction. This is your 100 and this is also 100. So the reaction forces, this is 2 meter distance, it is 1, it is 1. So now suppose this is R, this is also R because opposite reactions, anti W. So let us find first W, taking moment along this direction equal to 0 around A. So moment about A is equal to 0, that is equal to W into 4, and this is equal to 100 into 2 plus 100 into 3. So the value is 200% 600 divided by 150. I think it is 150. So the reaction at this point is, I need to solve first. 100 into 2 plus 100 into 3 divided by 4. Sorry, 125 it is coming. 200 plus 10, 500, 125 kilonewton. So now what is the reaction at R? R it is coming 75 kilonewton. Now here it is coming 75 kilonewton. So this is a cantilever beam. So you can just simply draw the cantilever shear force diagram for cantilever, and you can say that this is 75 up to here. Now at this point you have R is equal to 75. Okay. Now just you move ahead. You get suppose this is your 75 and you just move in this location. It is also coming 75, I think. Okay, yeah, because up to this point it is coming 75 where the load is applying. Now you can just get 25 in the negative direction, and again up to 100 point it is same, then again it is 125, and this is your shear force diagram. Okay, so this is your value for the shear force. I hope most of you doesn't get it. Let me explain here. So the upside is a cantilever, so the reaction R is happening, it is 75 kilonewton. So up to this you can say simply the cantilever part, the load is happening, it is 75, because you can take at any element and take the and split the part as like this, and you can obtain 75. And after that this point is coming. Here also no load is acting up to 100, so it is constant up to that point. And when 100 load is acting, take the elemental strip. Okay, this is 75, this is 100, so negative 25 will come, negative 25. Again it is constant up to 100, and it is again 100 will sum up in the minus 25, so it will be minus 125, and it is constant whole the length. Okay, this is your shear force diagram for this section. Anyone has any problem in this question? Okay, let me go ahead. So in the next question, this is your next question. A mass of 35 kg suspended from weightless bar AB. AB is weightless, and Cb at pin at A, the pin reaction at A would be. So what is the pin? Suppose you have a tension in the wire T, okay, and you have a vertical reaction Mg. So let us suppose this is your value is T cos theta, and here it is T sin theta. Sorry, the value is T sin theta. So equate the moment. T sin theta is equal to mg. First of all, you get the value of T, that is mg by sin theta. Now substitute the reactions. So at this point you have a only horizontal component, so it is coming like this, okay, that is opposite, that is the reaction force, that is equal to T cos theta. So your value for reaction is T cos theta, and that is equal to T, if you put, that is equal to mg cot theta. So reaction in x direction will be mg cot theta, and reaction in y direction is 0. So your answer is around answer is around 755.4. okay, this is kilonewton, because if you put cot theta, theta here, cot theta will be 275 divided by the value at this point. Let me, at this point it is 125, so put that 275 divided by 125, and cot theta it is 755.4. okay, the m and g is given. Now in the next question it is given a beam made of two identical bars AB. Okay, the same question that I said. We need to find the bending moment at A. So it is hinged at point A. So first of all we draw the question 3. We draw the diagram. Okay, and just put like this, C, B, A. So this P load is acting P at L by 2. This is your complete L, and this is your L. Now you need to find what is the bending moment at A. So first of all, and here it has support. So first of all, let's split the diagram. Here we have a B, and here we split at B, because here only reaction force is the Y reaction. So let us take at this way, and this is coming at this way, and you have a P, that is L by 2. So your reaction force, this is point B, this is point A. So RB would be the value, the value is L by 2 here, and so RB would be P by 2, and RA would be P by 2. So reaction here, this is also coming P by 2. Now this distance is L. So the moment at this point at the fixed support is P by 2 into L, that is equal to P L by 2. The answer is B. Okay, the next question is, suppose this is a given, we need to find the maximum bending moment. So this is a lengthy question, I think. Let me click it here. Okay, I am going to discuss at this point. So okay, okay, it is given a simply supported beam, that is given, and your this is your reactions at A and B, and a L shape is connected, that 100 Newton load is acting at, this is 100, this is 500, and this is 500, and you need to obtain the maximum bending moment. So first of all you need to draw the bending moment diagram. So what will be this? So first of all let's transpose this W load at this point and erase this point. Now if we just plug it like this, W in this direction, W with 100 load in this direction and this direction, and you know this is forming a couple. This is forming a couple. So just substitute 100 and 100 into 100, that is and a couple like this is m, and the value of m is 100 into 0.1 Newton meter. Okay, Newton meter, that is equal to 10 Newton meter. Now I can erase the bottom part. So the bottom part is, I can erase. The question has been transformed to this part. Now you can easily draw this diagram, bending moment diagram. Suppose, now what is the reactions at A? So let's take moment at A and when it equal to 0. That is RB into, the distance is 1000, that is distance 1000 mm, that is equal to 100 Newton into 500 plus, this is acting in this direction and this is also acting in this direction, means so that will be plus 10 into 1000. Why 1000? Because it is Newton meter, so I need to put it in Newton mm. So now RB value is, if I just equate it, it is 50 plus 10, 55, 60, sorry. I am getting 60 Newton value RB, and your RA is around 50 Newton. Now just draw the bending moment diagram. So this is your this diagram. So let's suppose at this x, mx. So your mx would be RA into x, that is 40 into x. So let's draw here, it is 40 into x linearly up to 100. Now 100 simultaneously it will add up. Okay, so the value then it will add up to sorry, it will not add up. Let's take at this point at the center, and this is your m. So m, and a load is acting in this direction, a couple. So couple is in negative direction, negative 10 and minus 40 into L by 2, that is 20. So the value is m is equal to 30. So here up to this it is 20, then I am going with 30. Okay, up to this, and now again it will fall linearly up to this. So your maximum bending moment is 30 Newton meter. So the answer is 30 Newton meter. I also explained this type of problem in my lecture when bending and shear force diagram is explained. So this is the question for this. Now a simply supported beam of length L subjected to a varying distributed load, okay, where x is the distance from the less support, the magnitude of the vertical reaction at the less support is. So first of all, it is given in sine of some function. So it is like this. So simply supported beam, and at x equal to 0 it is load 0. So it is like this. Okay, the load is in the form of sine functions. So and now it is given. We need to find the reactions that is at the less support. So I am just okay, you can just leave this question because it is very lengthy, because you need to find the area then equate to with the moment. Okay, so I can assume you can just leave the question, or let me explain, otherwise you will get confused when you are going to do it yourself. So this is A, this is B, and up to L it rotates about 3 pi. So this is your 1 pi, L pi, 2 pi and 3 pi. It is like this up to L, because it is given, and when it is L, sine 3 pi. So it is rotating around like this up to L. So you need to find now what is the reactions. So suppose first of all the reactions is RA and RB. So RB into your RB into L is equal to, suppose what is the total load. So suppose this is 1, this is 2 and this is 3. So first of all you need to integrate it with 0 to pi. So obtain the area and your net area will be, suppose this is area A, then this is area A1, A2, A3. Your area will be A1 plus A3 minus A2 because it is upward direction. So then the area will correspond to the load on the beam, and you multiplied with the center, that is L by 2. So what is A1? Because A1 and A3 everything is equal because sine function. So you can just simply say it is A1. Now integrate sine 3 pi x divided by L dx for 0 to L by 3, and you can get the value, that is the area for this load, and just multiply with this area into L by 2. Okay, then you can get RB value. That will be the procedure. Now next question is, for the overhanging beam, the maximum magnitude of the bending moment, maximum bending moment is. So in overhanging beam, what you need to do is, suppose this is your A reaction, this is your B reaction, the beam is overhanged at the end support, and you have given 100 kN uniformly distributed load up to this 10 kN per meter, and at the end you have 20 kN, and you need to obtain the maximum. So we have to draw the maximum bending moment. So what will be maximum bending moment? So if I just draw it, first of all find the RA and RB. RA is coming around 10 kN, and RB is coming 50 kN. Okay, you can just directly obtain that. I am not going to obtain that. So now the load is like this. This is 10 kN, this is 50 kN, this is your 20 kN here, and you have a UDL like this. Now for UDL, you know how to draw that. Suppose if I take at this distance x, your M would be 10 into x minus 10 kN into x square by 2. So this is a equation of a parabola. So it will be like this. Okay. Now after that, some point it will going downward, and up to this point it is this has a value, and after that you can just say it is a linear function because only point load is acting after that. So it is just a linear graph. So you can practice that at home, but I am discussing it. The maximum value here is 5, and here the maximum value is minus 40. So your maximum bending moment is minus 40 Newton meter. And now the next question is, so this is the next question. A cantilever beam OP is connected to another beam with a pin joint. You need to find the bending moment at this point. So this load you can just simply transform to like this. If I split this part, and this is your reaction at other end. So suppose this is acting at 10 kN at the center. So a reaction support will be like this, and opposite reaction will become like this. So this is RA, RB, and you need to find what is the reaction bending moment at this point. So what is RA? RA equal to 5 kN, RB equal to 5 kN because of symmetry. Now the 5 kN load is acting here also. Now at this is the distance 2 meter. So what is the bending moment at this direction? 5 into 2, that is 10 kN meter. So the value is 10 kN meter. And for this question, you can easily transfer this load at the center 10 kN and a moment this, and you can simply draw the bending moment at point R. You can simply find out that. So this is not any big thing for you. So this is okay for bending moment and shear force. So I am just giving you 4 or 5 minutes. Please ask anything if you want. Is it okay about the bending moment and the shear force? Hello. Hello. Can you write that in chat box? If you haven't understand, then also you can just say I will explain the part. Please can someone respond or write in the chat box. Am I audible? Hello. Can someone say anything? If I haven't understand, please also say that. Yeah, sir, I haven't understand the part. I will explain that. What you haven't understand? Please, can you just confirm? Okay, just say it. Yeah, because I need to discuss then bending and shear stress also. So, first of all, in bending, we need to discuss the concept. What I discussed in bending. So, what is bending? First of all, we just need to discuss. So, this is a fracture formula you need to remember. M by I is equal to sigma by Y is equal to E by R, and everything is coming from this only. Don't worry about it. Now, that's why bending moment has been taught to you before this bending stress, because you need to find the bending moment diagram, and in question it asks at the particular location what is the value. So you need to find the in question at that particular location what is the moment, then put that moment. And I hope you studied moment of inertia in your mechanics course. So you need to find the moment of inertia of the body, then you can simply obtain the bending stress in that. Okay, so this is one of the easy thing you can do. You need to just find the trick lies in finding the bending moment. If you know what is the bending moment, we can solve the problem very easily. So bending moment diagram, that's why it is taught before the bending stress. So and here I'm going to do that. First of all, the question is the beam, one having a square cross section and another circular cross section, are subject to same amount of bending moment. Okay. If the cross section area as well as the material of the beam are same, then so what the question is, suppose you have a circular cross section and a square cross section. Okay, a beam is made of these two things and have the same bending moment. So what is the meaning of that? Sigma is equal to sigma by Y is equal to M by I. You have the same M, you have the same you can say the material. So you need to find what is the value of bending stress in both the cases and their ratios. Okay, so let's talk about the area, because it is given their area is same. So what is the meaning? Area of the circle is pi r square or pi by 4 d square, that is equal to area of square, that is a square. So you can just easily obtain 2 by root of pi into a. One relation you can obtain from here. Now sigma in circle is m, that is given. Y is d by 2 into I. What is the value of I? I about this line is pi by 64 d raised to the power 4. Okay, sigma of square is m into, that is a by 2 divided by 1 by 12 into a raised to the power 4. So it is 6 m by a cube, and this is 32 m by d cube. Sorry, this is small d cube. Now if you just square take the ratio sigma circle by just wait a second, sigma circle by sigma of square, then it will be 32 m by d cube divided by 6 m by a cube. Now you can just simplify, and you also know the d to a ratio from here. So just put d to a ratio in this equation, and the value you are getting is, just a second, solving it. The value for circle to square, that is equal to 1.18. That means your circle has a maximum shear stress as compared to square. So the option is maximum circular beam experiences more bending stress compared to square. The option B is correct. Now second question is, the cross section of a two solid bars made of same material. These are the same thing. But you need to find their ratio of I1 and I2. So first of all, their area is given equal. So that the equation you got is 2 by root of pi into a, and you need to find the ratio of their I1 and I2. Flexural rigidity I1 and I2. So I1 is, for the square you can say 1 by 12 a raised to the power 4, and I2 is pi by 64 d raised to the power 4, and you know a to d ratio, so you can just simply obtain, and the answer is, I think I can just, I1 I2 is equal to 64 by 12 pi d, a raised to the power 4 by d raised to the power 4. Now a raised to the power 4 by d raised to the power 4 is pi square by 2 raised to the power 4. That means 64 by 12 into pi square by 16. So the pi value will cancel out 1. Your 16 for the 64. So the answer is 4 pi by 12 or pi by 3. So the answer is pi by 3. The next question is, consider a beam with circular cross section of diameter d. You need to find the ratio of second moment of inertia about the neutral axis to the section modulus. What is the meaning of that? Let us write the m by I is equal to sigma by y. So your section modulus is I by y, and your this value, this I is given, is the second moment of inertia. So you need to find I by section modulus, that is equal to y, and your maximum y value is d by 2. So the answer is d by 2. Okay. A circular cross section wire of 1 mm diameter is bent in circular arc of radius 1 meter by application of pure bending. It is given Young modulus, so you need to find the maximum stress. So it is given sigma by y is equal to E by R. So your maximum y is 0.5 mm, your R is given 1 meter, and your E is given 100 GPa. So value is 100 into 10 to the power 3 for megapascal into 1.0 mm, that is 0.5 mm, that is 10 power minus 3, divided by R, that is 1. Okay, so you will cut out this, it is around 50 megapascal, the value is. So the answer is 50 megapascal. So earlier this type of question is asked, but now this type of question is not asked. It is a glue type thing, so it is not asked in this today's format. So it is given a tapered cantilever of constant thickness. What is the meaning of constant thickness? You can say that in the means you can say that this is your front section, okay, but here it is like this, means it is like this at other section. So if I just draw it like this and I just project it like this, so this is your constant thickness, means you can say that if this is your bar, so this is your thickness is constant but the area is gradually increasing. The bending stress will be, means if it is applied with a P load, the bending stress will be maximum at. So you need to find where the bending stress is maximum. So it is question number 2. So first of all, what is the moment? Your P into L. So suppose your P into X is your bending moment, mx at any distance x, okay, and your what we say I, we need to find the I. So it is 1 by 36 bh cube, but as you know that your B is varying along x, so it is like suppose it is given whole is given B, so B by L into x, that is your B. So I can write it as 1 by 36 into B by L into x into h cube, that is equal to B by L h cube into 36 divided by into x. This is your I. Now m sigma by y is equal to m by I. Now if I write m, so it is m in, p into x into what is the value of y, that is t by 2, this is constant, and your I is 1 by 36 bh cube by L into x. So it is just cancel out, and sigma is coming as a constant value, it is not changing along x, so it is uniform towards the length. The answer is it is uniform towards its length. Okay, now you can easily draw the bending stress for this. You can just end the bending moment diagram. You can easily say this is equation is like this, up to at this point is 0 and up to this it is 10 Newton meter, and you can obtain the bending stress as sigma is equal to 10 Newton meter 10 to the power 3 Newton mm into y by 2, that is 5, divided by I, that is 1 by 12 into 10 to the power 4. You can easily solve this and you can get the answer. So 60, it is around 60 megapascal, this answer. So the next question is a massless beam having a loading pattern in this given and it occurs the maximum bending moment is. So first of all, when it is obtained maximum bending moment, you need to make the shear force 0. Wherever the shear force is 0, you can obtain the maximum bending moment, because you know dm by dx is equal to 0 for maximum bending moment, and that is equal to shear force. So first obtain the shear force for this diagram. So what is the Ra and Rb? First of all, the Ra is around 4.5 kilonewton and your Rb is around 1.5 kilonewton. Now draw the bending moment shear force diagram. You get it like this. I just because up to this there is no load, so a constant system, then a gradual load, it will be like going downward. So 1.5. Now at this location it is 0, so you need to find this location. So this value is 2, this whole value is 2. Okay, now this value is 1.5 and this value is 4.5. So you can apply the concept of similarity triangle, that is 1.5 divided by 4.5 is equal to x upon 2 minus x. This is x, so this is 2 minus x. You can obtain x as 1.5 from here, from B point. So you can say that a 1.5 meter from B point, or from A you can just obtain it is 0.5. So it is 2.5, that is 2500 meter. So this is your answer. And your maximum magnitude of bending moment. So at this point you need to find the bending moment. So that will be equal to RA, the value is 4.5. So you can simply write 4.5 into 2.5 minus 3 into 0.5 into 0.5 divided by 2. So this is your bending moment at this point, and this is equal to this value, and the answer is for this value is, you can just simply write the bending moment for this portion is 3.375 Newton meter mm, like Newton mm, kilonewton meter. Okay, now what you need to do is you obtain the bending stress. So you already obtained m. You just simply substitute the value sigma is equal to my by I. You can get the maximum bending stress. So here the question is, it is given again a simply supported beam with a UDL. The maximum bending moment is, for the UDL you know the maximum bending moment is ml square by 8. Sorry, wl square by 8. So what is w? 1.5, that is 10 to the power 3 Newton meter, into L square, that is 36, divided by 8, that is here. You can just simply solve, and your maximum bending moment in case of UDL is your value is around just a bit a sec. .75. The value is coming 6.75 kilonewton. So this is 6.75 kilonewton meter. Okay, kilonewton meter. Now what is the maximum value of bending stress? Just simply put the value sigma is equal to 6.75 into 10 raised to the power 6 Newton mm into y, that is value is 75 mm diameter. It is a circular, so you can write it 75 divided by 2 divided by pi by 64, 75 raised to the power 4. So you can simply obtain the maximum bending stress also. The maximum bending stress is coming 162.98. And the next question is, for the component loaded with force F in the shown figure, the axial stress at the corner point P is. So you can just, I made you explain, this is the eccentric loading problem. So you can just substitute it like P, that like F, and a moment like this, that is equal to P into what is L minus P. So this is L minus P. This is your two things. Now this will F will act will cause sigma axial as at P is F by A, and because of this bending, this portion is also a tensile condition. So sigma bending is equal to P L minus B into Y, that is again B, divided by I, that is 1 by 12 to B whole raised to cube. So you now add up these two equations and you can get the maximum stress, axial stress at this corner point. Okay, so the maximum value of stress is F into 3L minus 2B upon 4B cube. Now here also a question is given. You need to find the bending stress at the point A. So just you can simply take, this is a couple formation. You can see that these two loads are forming a couple in this direction. So these two reactions are also will form a couple in this direction. So it is P into the distance is what is L. So everything is L. So it is P into L, that is equal to reaction into your L plus L plus L, 3L. So the reaction will be P by 3. So P by 3 in you can say in this direction, and P by 3 in this direction. Now draw the bending moment diagram using the same concept, and you can get it like you can say you can draw the bending moment diagram, then you can obtain what is bending moment at point A. So as I used to get, I think it is 0 at this point. Okay, now the next question, same question here. UDL is given in the cantilever. You need to normal stress at point P. So first of all, find the maximum bending stress. What is the bending stress at point P? So it will be 100 into L by 2. So it will be 100 into L square by 2, that is equal to 50 Newton meter. Now put that equation in sigma, that is m50 into your distance d by 2, that is your 5 divided by I 1 by 12 into 10 raised to the power whole cube, a whole power 4. So you can solve this and you can get the sigma bending at this point is 300 megapascal. Now question number 11, you can just simply get from the same question that the UDL, you need to find the maximum bending stress. So it's the same problem. Sigma is equal to m max y by I. You know m max is for the UDL is WL square by 8. Put that value, you know y, you know I, you can simply solve this problem. And this question is also the same as the earlier one. I just told sigma by y is equal to E by R. Put that value, you can obtain sigma. So up to bending stress, any problem? Hello. Please respond because I have only 4 minutes left up to 1, so I need to cover the shear stress because there is only 3 stress these questions are. So you can say how the easy format is. So if this question is given one of the, for the transverse shear stress for a rectangular section. So I explained in my shear stress lecture, the shear stress for any section is a parabolic in nature. So the option B is correct. And in GATE 2014 it is asked, consider simply supported beam, this and this vertical load at midpoint, the maximum shear stress to the maximum bending stress. So maximum shear stress, you know, that is 1.5 times, maximum shear stress is 1.5 times average. So that is 1.5 into P, that is the load is acting divided by area. The area is 2H into H, that is 1.5 P by 2H square. And your maximum bending stress is, because it is simply supported, so M is WL by 4, this is your maximum load, maximum moment at the center, and your sigma is WL by 4 or PL by 4 into with H by 2 divided by 1 by 12 into H cube into 2H. So you can just take the average of tau max upon sigma max and you get the value as 0.01. So the answer is 0.01. So this is the up to bending and shear stresses. So I am ending the session now. So I am just asking you how your means you can see the questions. So how you are feeling? Is the questions is easy or difficult? Please respond because it is 1 PM now. Again I have to come at 2:30. So please respond fast. You can be free early. Hello. Can you say?